All right, following our very exciting fire drill, we're going to pick back up where we left off. And today we're working on dividing fractions, but you need to know an awful lot about fractions before you can divide. So I'm just doing a quick review. To simplify, I want you guys to fill in these words so you've got these notes. To simplify fractions, you need to find a common what?
Denominator.
Not denominator.
Numerator.
Nope.
No. Fraction. Multiple.
I've heard a lot of different words. Which one is it?
Denominator.
Think about what you're listen. Hold on, Jalen. Listen to what I'm asking, and think about what you've got to do with that. Okay. So to simplify a fraction, we're looking for a common what? Factor. A number that goes into both the other numbers. So this is factor. Okay. That is shared between the numerator and the denominator. So we're using basically the GCF method here, right? We're pulling out that greatest common factor. Then you're going to divide the numerator and the denominator by that common factor. How do I know I'm done? When the numerator and denominator only share a factor of 1. That's the deal, right? And that's the same thing when we're doing GCF or LCM or any of that stuff. So it's the same rules that apply, all that good stuff. Anybody have a question on that? So real quickly, just to see how we do that, if I have 4/8, and you can see this on your paper, it might be a little bit more clear. But if you see that I've got 4/8, if I divide the top and the bottom by their common factor of 2, I get 2/4. And then there's still a common factor of 2, so I can keep going until I only have a common factor of 1. Let me just show you a quick method using the sled to simplify fractions if you like that sled method. For example, let's do 12 and 24. If I put 12 and 24 on a sled, here's my numerator, right? Here's my denominator. What's the common factor between 12 and 24? Let's do 6 just because I heard that first. 6 goes into 12 how many times? 2. And how many times into 24?
4.
And what common factor do these guys still share? 2. And I get 1 and 2. So look, this was your numerator. This is your denominator. You've now made 3 equivalent fractions. 12 24ths is the same as 2/4, which is the same as 1/2. So if you like the sled, you can totally use that for simplification,
Or
okay?
you could make more, like you could do like a smaller number.
Yeah.
Like 4.
Yep.
And then it could be 2/4, 4/8.
Absolutely.
1/2.
So that sled creates those simplification fractions, and it also gives you equivalent fractions. All right, does anybody have a question on that? So if you like that method better, if it helps you get organized because you've been doing that, totally fine. If you like to use this method where you divide by the top and the bottom by the common factor, you are absolutely entitled to do so. And when we do that, we get 1/4. Nope, I'm getting there. I haven't gotten anywhere yet. We're just doing a quick review. Didn't I drop something? All right, so next on the agenda here, anybody have a question on that? Yes, sir. Number 6? All right, well, let me ask you a question, Dean. Using those divisibility rules, right? What goes in it all? 2. We can definitely divide by 2. So let's use the sled just so you can kind of see it. How many times does 2 go into 504? Yeah, what do you think, Deon? 252. How did you get that so fast in your head? You're right. What method did you use? Shh. Okay, so basically you took half of 500 first, right? Because that's what dividing by 2 is. And that got you the 250. And then half of 4, which is 2. So when you put them together. And what's the, what do you get when you divide by 2 here? Akshay?
261.
All right, everybody agree?
Yes.
Okay, 261. All right, let's use some more of those divisibility rules. When you add these guys up, what do you get? 9. What do you get when you add these up?
9.
So what goes into, if they both add up to 9, what number can, 9 or 3. Let's do 9 though, because it's going to make them smaller, right? Now let me show you how I would do this on paper. 9 goes into 25 how many times? 2, 3, 2, 2. That's 18. How many are left over? 7. Put the 7 over here. Now you got 72. 9 goes into 72 how many times?
8.
So what I did was, we knew that 9 times 2 was 18. I needed to get all the way to 25, so that left me with 7. 72. It's just doing long division shorthand. If you didn't get it, you can always go do long division out to the side.
Yeah, that's like
Okay. 9 goes into 26 how many times? 2. And that leaves me with 8, right? 81. 9 goes into 81 how many times? 9. And again, if you didn't see that, if you'd rather take it out to the side and do long division, that's totally fine. Okay, so the way I did that was 9 goes into 26 2 times. That is equal to 18. So that leaves me with a remainder of 8. So I just put the little remainder here and match it up with the next number that I would have dropped down. Okay. So again, if that doesn't float your boat, if that's throwing you off, that's fine, but that's how I do it. Do 28 and 29 share any other common factors? Nope. So what is the biggest common factor we can take out of here? 18. And that leaves us with a fraction of 28 over 29. Okay, do you see that? So that's why those divisibility rules come in handy. They help you determine quickly if a factor is even worth bothering with. Okay? Hey, anybody have a question on simplifying? Awesome, we're going to move on. Here's a quick review of multiplication rules. And then we're going to actually get to division today, but I think we can do it all. So there's a couple of things I want you guys to know, and I'm going to actually do all these problems. But multiplying fractions, okay? Here's with a model where you take a half times 2/5, and we only want half of that 2/5, so that would leave me with 1/5. But let's take an example where we do it numerically because I think that makes the most sense. You can always simplify before you multiply by finding common factors top to bottom in your problem. So if you look at this example, we started with 7/6 times 3/9, right? Looking top to bottom, do you see any two numbers in that set that share a common factor?
Yeah.
What? Give me a pair. 3 and what? 3 and 6. All right, so 3 and 6 share a common factor of what, Matthew?
3.
Absolutely. And if I divide by 3 here, I get?
1.
And here I get?
2. Wait, whoa.
Okay, let me say that again. I asked you if you saw any common factors top to bottom. Matthew said he saw a common factor of 3 in 3 and 6. Okay, notice it's got to be one number in the numerators, one number in the denominators. He said he saw a common factor of 3. So to simplify that, we're going to divide by that number. So what is 3 divided by 3? 1. And 6 divided by 3 is 2. Now that I've simplified, do you see any other common factors top to bottom? Dean?
6 and 9.
Nope, 6 and 9 are not top to bottom.
Oh,
Hannah?
2.
2 goes into what though, honey?
Oh, wait.
Top to bottom, we're looking for common factors, something from the top and something from the bottom. Do you still see it? Or no? Luke? 1. Sure, 1's a common factor of everything. Hannah?
3.
3 with what? 3's already been crossed out. We're left right now. We've got 7, 1, 2, and 9. Do you guys see any common factors in the top that share something in the bottom?
1.
Just 1, right? So we're done simplifying. Guess what? If you simplify before you multiply, you won't have to simplify at the end. And your numbers are easier. What's 7 times 1?
7.
And what's 2 times 9?
18.
And that's our answer. Now, if you didn't do that, right, we would have multiplied across because that's how we do multiplication. This would have been 21, and this would have been 54, and then you would have had to simplify. And those numbers are a lot uglier, right? So if we simplify before we multiply, we will find that at the end you don't have to do any simplification if you find it all. And the numbers you're dealing with are going to be much smaller and more likely to be in your head. That needs to go away. Both of you. Okay? All right, which is a lot harder? Simplifying before you multiply? All right, well, no, it's not. We're going to get there. Because simplifying 21 and 54 is bigger numbers, and they could get bigger and bigger and bigger. We're going to get them small. So let's take a look at the examples. We're going to do a few of these because this is kind of, there's only one more thing to add when we go to division. Look at the top numbers and the bottom numbers. Do you guys see any common factors that they share? Just on number 1. Do you see any top factors that share anything on the bottom? No. So if we don't, we just multiply. And when we multiply fractions, we just go straight across. So what's 1 times 3? And 2 times 5? Do 3 and 10 share any common factors? Because we know that because we couldn't find any in the first place. So we know there's not going to be any at the end if we did our job right. Now let's look at the second one. Anybody see a common factor top to bottom? Gabriel?
3.
The 3's. What factors do they share? They share 1, but what other factors do they share? 3. I'm asking Gabriel. So the 3's share 3's. So 3 divided by 3 is?
1.
And 3 divided by 3 is?
1.
And 1 times 1 is?
1.
And 1 times 4 is? Thank you. All right, let's take a look at the second, or number 3. Do you guys see any common factors, top to bottom, that share? I don't know. 2 and what? 2 and 6. What's the common factor between them? 2. So we divide by 2. What do you get on top?
1.
And on the bottom?
3.
Any other common factors, top to bottom? No, I do have 2 3s in there, but they're both in the bottom. I can't simplify. Any other common factors? So we're just going to multiply. What? What do you see? Okay. So 1 times 5 is? And 3 times 3 is? So see what I'm doing is every time I'm making those numbers as small as I can. So the multiplication gets easier. The simplifying gets easier. It's all easier if we do it first. Let's take a look at this problem right here. All right, Vinny, you got one that they've got in common? All right, well then watch. We're going to do some more. Jayla, give me 2 numbers, top to bottom, that have a common factor. 3 and 12. Now, Vinny, look. 3 and 12 are the 2 numbers he found. Jayla, what factor do they share in common? They have a 3. You're going to get a 4. But the 3 is what can go into both of them, right? When I divide here by 3, what do I get, Vinny? 4. When I divide 3 here, what do I get? 1. Now look, top to bottom, do we still see any common factors?
No.
What do you see? 4 and 4, right? Guys, look. This 4 and this 4 share a common factor of what? 4. 4 goes into both of them. Bless you. So we're going to divide again. Vinny, 4 divided by 4 is?
1.
Vinny, 4 divided by 4 is? 1. There we go. Now look top to bottom. We've got 1, 1, 7, 1. Any common factors other than 1?
No.
Now we can multiply across. 1 times 7 is?
7.
And 1 times 1 is?
1.
So what's the actual final answer here? 7. Remember that you do not put that, you don't need that extra 1 on the bottom. It doesn't make it wrong. But 7 divided by 1 is 7. Didn't I ask you to put that book away? Okay. Did you already do these in Mr. Bother's class? That way you're, okay, then you can read for a second if you're ahead. You just have to explain to me, otherwise I don't understand. All right, anybody have a question on that one? Vinny, is that making a little bit more sense? We're just taking out common factors. We're dividing. So in the end, if you'd waited, you would have been doing that at the end. But if we can do it before we multiply, those numbers are far easier to work with, right? All right, let's take a look. What do I have to do here before I can multiply?
Make it improper.
Yeah, I got to make that mixed number into an improper fraction. So I do that by multiplying first, right? I have 5 whole pieces in this one, plus an extra piece. So how many pieces do I have?
6.
How many did I need to make a whole? 5. I'm still multiplying by 20 over 3. Now, top to bottom. First of all, does anybody have a question as to how I got there? Yeah, Hannah? Okay. Top to bottom, what do you guys see? Give me something that you see. Dean? 6 and 3. What factor do they share, honey? 3. When I divide by 3, I get? 2. Look what I'm doing. When I divide by 3, I get? 1. Sorry, I'm going to move this up a little bit. All right. Any other common factors, top to bottom? Matthew?
5 and 20.
5 and 20, what do they share?
5.
Okay, when you divide by 5, you get?
1.
And you divide by 5, you get?
4.
Any other common factors, top to bottom? Okay. Katie?
4 and 2.
I knew someone was going to say that because everybody does. But are those top to bottom factors? Right? So, and I'm glad you did it. I was hoping somebody would. Because the deal is that you can't go across. You can only simplify top to bottom. So we're looking for one number in somewhere in the top that can have a common factor with something in the bottom. So since 4 and 2 are both numerators, we can't simplify. And the only thing we have on the bottom are 1s. So we're good. So now we multiply across. What do we get on top?
8.
And on the bottom?
1.
So what's the actual answer here? 8. Now, what do I have to do to this problem before I can do this one?
You have to make it.
Go ahead, Armando.
You have to put a 1 over a 2.
You got it. That way we've got a numerator and denominator. 2 over 1, yep. Raise your hand if you can tell me a common factor that you see. Summer. 2 and what?
2 and 6.
What factor do they share?
Well,
2. So when I divide by 2, I get
1.
3. And when I divide by 2, I get?
1.
Any other common factors, top to bottom?
No.
Nope. So we're just going to multiply across. We get what?
5.
5 over?
3.
And that's it. And I'm okay with improper fractions as answers. Yes, ma'am.
I have a question.
Uh-huh.
So are you allowed to do so it says 5, 6 divided by 2 over 1.
Times 2 over 1. Uh-huh.
Times 2.
Uh-huh.
Can you do let's say it was 3, 6 times 2 over 1.
All right, let's look.
3 and 6.
So 3/6. Let me get my screen back to its regular space. 3/6 times 2 over 1. Yeah, you're looking any factor in the top that can match with one on the bottom. Yep. What's their common factor? So we divide by 3, we get a 1. Divide by 3, we get a 2. Yep. Can we still go on? What else do you see? So 2 and 2, they share a factor of 2. Divide by 1, 1. I'm actually going to end up getting this as 1. Okay. Because if I take 3/6 times 2, right, that's a half, times 2, that makes a whole. All right, anybody have a question on multiplying? So we all got that, are you sure?
Yes.
You know what the cool thing about that is? If you've got multiplying, I'm going to show you one extra thing, and then you can do dividing. So on the next page, page 24. Okay. Actually, we're going to come back to page 24 in a second. We're going to go to page 25. Okay. We're going to come back to 24 in a minute if we've got time. All right, so actually, you know what? I'm lying. We're going to the right side of 25. Sorry. Typically, when we divide fractions, a reciprocal, that's the word we're going to talk about today, is one of, oh wait, sorry, not a reciprocal. It is reciprocal. Sorry. A reciprocal is one of two numbers whose product is 1. So if we multiply them together, we get 1. It is the result of basically flipping over a fraction, exchanging the numerators and the denominators. So for example, 3/4, its reciprocal is 4/3. And 2 is really 2 over 1. When I flip that over, it becomes 1 over 2. And that's a really important concept. I want you guys all to understand that knowing what a reciprocal is a required thing for your quiz and your test and anything else we do in here. It's also up on the board over there. Okay? Now, it is. We're going to talk about that. So, everybody in here just told me you were proficient multipliers, right? Well, guess what? Division, okay? Division is going to require you to do one extra thing, and we're going to talk about it. Somebody tell me, what's the reciprocal of 2/3? Raise your hand. Who haven't I talked to yet today? Aaliyah. 3 over 2. What's the reciprocal of 3/13, Joe? Shh, Joe. What's the reciprocal of 3 over 13? You need to be paying attention, kiddo. Kyla, what's the reciprocal of 3 over 13? There we go, 13 over 3. I'm coming back to you, Joe, for number 5. For number 5, yeah. Be prepared. Number 3, Vinny.
10/9.
You got it. Those are the reciprocals of those numbers. All right, number 4. What do we have to do first, Armando?
You have to make it into an improper fraction.
Okay, and when you do that, walk me through the steps.
4 times 8 is 32.
4 times 8 is 32.
Plus 3
Uh-huh.
is 35.
35, and what's my denominator going to be?
8.
Okay, now its reciprocal is,
8 35.
there we go. Okay. Yes. Awesome. Awesome, you should. That's why this is a review. Noah. Not Noah. Joe, sorry. What is this fraction, and how do I flip it? Wait. Yep, the reciprocal is 1 over 5, because remember, there's a little imaginary 1 down here. Okay? Vinny, you want to do, oh no, I already got you. Somebody who I haven't talked to yet. Matthew, do number 6 for me.
7 times 9 is 63, plus 5, 68, and then 9, so 9, 68.
You got it. Beautiful. And we've already done all those. So that's a reciprocal. Anybody have a question on what a reciprocal is? Okay. So now we are going to go to the actually very last page of our MSG. Okay. And we're going to talk about how to actually divide fractions using that algorithm. So guess what? Again, how many of you guys can find a reciprocal? Put your hands up. Can find a reciprocal. How many of you can multiply fractions? Well, then you guys can divide, because let me show you. Keep, change, flip, which you've probably heard before, is listen to me carefully. Keep, change, flip is a mnemonic device that we use to remember what to do. It's not really a mathematically sound device, but it does help us remember. Keep means whenever we divide, we're going to keep the first fraction. Okay? Change means we're going to switch from division into multiplication. And flip means we're actually going to multiply times the reciprocal. So if you know how to multiply and you know how to find a reciprocal, you can divide. Oh, thank you. So if we've now got the multiplication and the reciprocal part down, then all you have to do right now is keep, change, and flip it over, and you're going to be good. So let's take a look at what that looks like. Here in this problem, okay, we're keeping the first fraction. So if you notice in all the three things after it, 4/5 stays exactly where it was and in the same order. We change division into multiplication, and that 2/3 becomes 3/2. Now we can actually do the math. Does anybody see a common factor top to bottom here? Dean?
2 and 4.
2 and 4. What factor do they share?
2.
2. Divide by 2 on top, I get?
2.
And on the bottom?
1.
Any other common factors, guys?
No.
Nope. So Lillian, when you multiply across, what do you get on top, honey?
6,
And on the bottom?
5.
You got it, and that's your answer. And I'm okay with improper fractions. You can also change it into a mixed number. Okay? Let's take a look. I'm going to do 1 or 2 more examples, and I'm going to let you guys do some examples and practice it and make sure we're good. We got less than 10 minutes left. So in this problem, we're going to walk through just a couple of them together. In this first problem here, we keep, what do we keep?
Keep the less number.
Which is 5/8, right? Our division turns into what? Multiplication. And I'm going to use a dot because we're going to get in that habit. Remember that a dot is the same as an X. And instead of 2/3, now we're going to be doing it by 3/2. Yep, 3/2, 3/2. Anybody see common factors top to bottom?
No.
Nope. So guess what we do?
Just add right across.
Not add.
Multiply.
Multiply right across. 5 times 3 is?
15.
And 8 times 2?
16.
That's it. So I didn't really teach you anything new today, right? Hannah?
So for keep,
Uh-huh.
like, wouldn't it just change or flip? Because why would you keep it?
You're keeping that first fraction. It doesn't change. We're not flipping it. We're not doing anything. We're keeping. So look at the example up here. 4/5 stays 4/5 in that position the whole time. We keep it. Then we change our operator from division to multiplication, and we flip the fraction over, okay, to multiply. Yes, sir?
I learned this in 5th grade, and to remember it, we called it KFC.
Yeah, KFC, I know. And it's KCF for me, but because really what I want you to do is kind of go left to right, but if that's how you remember, I don't care. Dean?
So why don't you also, like, you flip 2/3 into 3/2? Why don't you flip the 5/8 as well?
Then we're totally changing the entire problem. So let me show you. We're going to go back in a second and just look at the diagram. If we have time, if not, I'll do it tomorrow. And it might make a little bit more sense. But what we're basically seeing here is, let me show it to you in a picture, and that might make it clearer before I muddle it. We'll do it in 1 second. Hold on. All right, so actually, Regina, why don't you walk us through it? So the first, number 2, what do we do first? We keep what?
3/10.
Your name is Regina now? All right, we keep the 3/10. And instead of division, we're going to have multiplication. And 1/2 turns into?
2 over 1.
Shh. Unless your name is Regina, I should not hear your voice. All right, Regina, do you see any factors top to bottom?
Yes.
Which ones?
2.
10 and 2, what do they share, honey?
5. No, I mean 2.
2. When I divide by 2, I get?
5.
And when I divide by 2, I get?
1.
Okay, and on top, 3 times 1 is?
1. 3.
3. And 5 times 1 is?
5.
Is that what you got?
Yeah.
Then you got it. Why don't you guys work on a couple of these? I'll be putting up the answers in a minute so you can check them. You did? I'll put up the answers. I'm going to work them right now. But that's it. That's all I had to teach you. And for the most part, that pretty much encompasses most of our unit. So we're going to be reviewing pretty much after this. I'm going to do these problems so that you guys have them if you want to do them at home as practice. I'm going to do them right now so that they'll be on the video when I post it. We keep, we change, we flip. Anybody see a common factor there?
No.
4 and 10, right? They have a common factor of 2, so let's get rid of that. And I think that's it. And I am A-okay with that. It also can be 3 and 3/5. Either one.
Wait, how does 4 and 10?
4 and 10 have a common factor of 2. 2 goes into both of them. They're both even, right? Okay. Yeah, you gotta flip. You have a question, Lee? You're not what? Feeling good? Yeah, you don't look good. Do you need to go to the nurse? Okay. Write a pass on your agenda and I'll send you right down. And then, Kyla, if you want to, just collect your belongings and put them over here so that when the next class comes in, they're not in the way. Yeah, and I'm doing them up here so you can see them when you're ready to look up. What, honey? Yeah, leave it right there. So. You knew I've been doing this for a long time, right? You got a question about, did I make a mistake? Because I could have.
Oh yeah, number 6, you made a mistake.
I did? Number 6?
I
I don't think so.
did
Wait.
one problem and you did all 9.
We're good. You got 4 minutes. Thank you. Well, I've been doing this for a long time, right? So, and I can see those patterns. And remember I told you guys that we don't use calculators in here very often, at least not this first unit? Because the more you see the patterns, the more those numbers jump out at you, the more you don't have to think. Like, I didn't have to think about what common factors, all those things come naturally to me, just like my name. Anna, come over here so we're not on the recording. I'm gonna stop the recording here, and this will be up on the blog for you guys to take a look at tonight if you need it.